Hello friends, welcome to part 1 of Kinematics, and I'm going to complete this chapter in 4 or 5 or maybe 6 videos because in a single video I cannot complete. Okay, so in every single video I'm going to cover 2 or 3 topics, and in each video previous year's questions of NEET and JEE will be solved related to that topic which is being discussed in the video, in that particular video, right? And before we start, please subscribe the channel if you are new to my channel. Also share with your friends, hit the thumbs up button if you like my videos, and also hit the bell icon so that you get notified when new video will be uploaded. And one video is made on the topic units and measurement on the topic dimensional analysis. Link is given in the description box, so if you haven't watched that video, then you may go through. The link is in the description box. So now let's continue. Here you see motion in a straight line, or one-dimensional motion, or you can say rectilinear motion. So what do you mean by rectilinear motion or one-dimensional motion? Suppose we have an object here with this with respect to this coordinate system. Its position is x, y, and z. It moves in this direction. Suppose its path is parallel to x-axis, right? And the new coordinate will be x dash, y dash, z dash. So here you can see in this motion only one coordinate is changed, right? And other two coordinates are same, right? They are not changed. Only x coordinate is changed because it is moving along x-axis. If it moves along y-axis, then only y coordinate will be changed. So now you see such kind of motion where only one coordinate is changed. That motion is called one-dimensional motion or rectilinear motion. Only one coordinate is changed. So now let us consider this is suppose x-axis, and this is the position O. This is an object at time t is equal to 0. This is the position 0 here, suppose, and it is moving in this direction, right? Moving in this direction, and this is the position A. After some time, this is the position A, and it comes back to the position B, suppose. Okay, so now this is the initial position, right, where it is 0, and it moves in this direction and reaches to the point B, sorry, not B, A. Then again it returns, or it comes in backward direction, then it reaches the point B, right? Then in that case the distance is given by total length of the path. Okay, this is the forward motion, and distance covered by the forward motion, and this is the length of the path in backward direction. So total length of the path is the distance. And what is displacement? Displacement is the final position minus initial position, right? So what is the final position here? Final position is this is the initial O is initial position. Just wait. This is the final position OB is the final position, so we're gonna write OB, then minus initial position is 0. Initially this because this motion starts from this origin O, right, where position is 0, so that's why the displacement is OB. Now here you see another example here. So this is 0, 1, 2, 3, 4 meter, and this is an object. Its position is 1 meter. It is at 1 meter with respect to the origin O at time t is equal to 0 seconds, suppose, and it moves in forward direction. Then this is the position after time t, suppose, right, 4 seconds, and it comes back to the position 3 meter with respect to the origin O. So this is after 5 seconds, right? So going forward, then again coming back, right? So the distance travel, this is a distance travel. Here you see total length of the path. So first it moves in this direction, right? And this part is, what will be the length of this part? Length of this part is 3 meter plus. Then again it is coming back to this position, 3 meter. So from 4 to 3 meter, distance travel is 1 meter. So total distance will be 3 meter plus 1 meter, that will be 4 meter, right? And displacement is final position is 3 meter, initial position is 1 meter. So 3 meter minus 1 meter, final minus initial position, that's going to be 2 meter. And time taken is 5 seconds. So what is the time taken? Time taken is 5 seconds here. Total time taken 5 seconds. So what will be the average speed? So when we say average speed, so it's going to be distance by time, right? Here distance travel, which is the total length of the path, is 4 meter and the time is 5 seconds. So 4 by 5 meter per second, which is going to be 0.8 meter per second. And when we say average velocity, displacement by time, here the displacement is 2 meter, right? And the time taken is 5 meter. So 2 by 5 meter per second, that's going to be 0.5 meter per. Now you see, what do you mean by average speed and average velocity? Now you see, suppose this object is moving in a particular direction, right? So it is not necessary that its speed and velocity will be same, will be constant at every instant of its journey, right? So when we find the velocity or speed, when we find speed, distance by time, total distance traveled by time taken, then it gives the average velocity or average here when you take distance, then it's gonna give you speed, average speed, right? Average speed during this period of time of t seconds, right? Okay, so here the time taken is 5 seconds, right? So we have found here average speed is 0.8 meter per second. This is the average speed from 0 second to 5 seconds. This is not the instantaneous speed. This is not the speed at 5 seconds. Okay, this is not at 5 seconds. It is from 0 to 5 seconds during this time period, not an instant. This is the average speed during this period of time. So similarly, this is average velocity during the period of time from 0 to 5 seconds, right? So hope you have understood this. Now let me take an example to explain the instantaneous speed and instantaneous velocity. Before we discuss instantaneous speed and instantaneous velocity, let me give you very important mathematical tools. Here you see. Let me go to the next slide. Okay, so mathematical tools. So here we need ddt of t to the power n, right? That's going to be n into t to the power n minus 1. And integration of t to the power n dt is given by t to the power n plus 1 by n plus 1. And if you have upper limits and lower limit from a to b, if you integrate this, then its value gonna be, first you have to put the upper limit b here in place of t, then you have to put the lower limit. Okay, on putting the b, putting t is equal to b, we have got b to the power n plus 1 by n plus 1. This is the value we have got. Putting upper limit, then put the lower limit a, then you will get the value a to the power n plus 1 by n plus 1. Then you have to subtract these two. That's what we're gonna get, right? Now when we will discuss about the instantaneous velocity and instantaneous speed, then you will get to understand where to use this formula, right? And when we will solve problem, this formula you're gonna understand how and why this should be used and where those formulas should be used. Okay, so I think you have already got in mathematics, if you have studied differentiation, if you have got this formula ddx of x to the power n into x to the power n minus 1, and you have got more formula, but here we are taking only this few, okay, and if we need other formula then I will give you later, okay. So now for the time being, just remember these three, right? So here you see these two are same formula, but here the variable is different. Here we have taken x and here we have taken t, just same thing, but variable is different here, okay, nothing else. So hope you have understood. Now remember one more thing. Suppose if you have t to the power n, you have a constant here. When you will differentiate it with respect to t, then this c is suppose constant here. It may be 2, 3, 4, 5, any number. So then it should be taken outside. Then we will differentiate t to the power n only, okay. And we will understand what is this differentiation, this differential coefficient mean in the next slide, okay, when we will discuss about instantaneous velocity and instantaneous acceleration, instantaneous speed, right? So now let's go to the next slide, okay. So now let me draw a graph here. Suppose we are taking an example of motion such that at t is equal to 0, its position is at origin 0, at this position, and it is moving forward, and after 1 second its position is this, suppose 0.5 meter with respect to the origin. After 1 second, t is equal to 1 second, and after 2 seconds it reaches to the position 2 meter, right? And after 3 seconds it reaches to this position 4.5 meter when t is equal to 3 seconds. Now if you observe the pattern, if you observe the way the position is changing with time, position with respect to time, how the position is changing with respect to time. So here you can see it can be written as 0.5 into 1 square, right? So here 1 is the time, 1 second, right? And again after 2 seconds, this 2 meter position that can be written as 0.5 into 2 square. 2 square is 4 into 0.5, that's going to be 2 again. And here again you see after 3 seconds, this position can be written as 0.5 into 3 square, right? After 3 seconds. So we can say that position is a function of time t. That means position changes with time, it varies with time, right? And in general it can be expressed as 0.5 into t square, because here you see these expressions here, these are nothing but t square, right? 0.5 t square, 0.5 t square, right? And if you draw the graph of these situations, here you see, and 0.5 is constant here, this part is constant here. So if you draw the graph, right, then this should be something like this. So here position is taken in meter and time is taken in second. So we're gonna get such kind of graph, right? This kind of graph we're gonna get, right? Suppose at a time, at an instant t1, suppose, and at another instant t2, the positions are, suppose, so let me draw a code joining this. These are the positions. It is suppose xt1, at xt1, this is the position at xt2, right? xt2, and I have drawn a code here, and from this position we have drawn a perpendicular here, right? Perpendicular here, and this is nothing but xt2 minus xt1, right? xt1, let me represent it by del x, okay? And this difference, this interval of time will be given by t2 minus t1, right? This is t1, this is t2, so this portion will be given by t2 minus t1. So hope you have understood, and let me write this one as del t, okay? So let me write all these things properly, okay? Just wait, let me write all these things properly, just wait. So give me a moment, okay? So this is the position at t1, t2, and right, this is t2 minus t1. That means this change in position, the change in position, okay, this is the change in position, right? So hope you have understood this. So this is given by this is x2, right, and this portion is x1. So this portion will be xt2, sorry, not x2, xt2 minus x of t1, right? So hope you have understood this. Let me consider this one as del x, okay, and this is t2 minus t1, right? Let me write del t here, and this is del x, okay. So then the average velocity during this time period t2 to t1 will be given by this average velocity will be given by t2 minus t1, right? This average velocity will be given by x position at time t2, that is final position, and position at time t1, that is initial position, divided by t2 minus t1, okay, which is nothing but del x by del t, right? We can say this is average velocity, right? So now you see this is the perpendicular, and if you see if you extend this, let me draw it separately. This is the curve, suppose, and this chord is extended. Now this chord is extended, and suppose this chord makes theta angle with this x-axis. Then, sorry, here not at x-axis, this is time axis. Then here you see we have drawn this perpendicular which is parallel to this time axis. This will be parallel to time axis, so this angle will be also theta, right? This angle will be also theta. That means here you see this is the theta, okay. Then we know that perpendicular by base, that is tan theta, so which is the slope of this chord. So we can write this is the slope of the chord joining the position xt2 and xt1, right? Joining these two positions, and this slope gives the average velocity, right? Now let us find the instantaneous velocity. Let me draw the diagram again here. Same diagram, let me draw it here. Okay, this is the diagram t1 t2 time, and corresponding positions are xt1 xt2, right? So here you can see, let me write all these things here, okay, that's gonna help you understand better. Okay, now you see, so this is the angle theta, right? Now suppose we are to find the velocity at any instant t, suppose then we have to take t tends to 0. That means here you see, so we have taken this difference t2 minus t1, very small, t2 and t1, these are very close, suppose. That means we have assumed that these two points xt2 and xt1, these are very close. Suppose at an instant t, suppose we are going to find the velocity at an instant t. So at an instant t, how to find the velocity at this particular position? So let us assume that these 2 points are very close. This xt2 and xt1 are brought very close, right? Very close. Suppose you see, let me take this point is now here, and this point is suppose here. Then this will be the chord joining these two. Similarly, if you bring these two more closer, okay, then this will be the chord, and when you bring these 2 points very close, that means this time separation tends to 0, very close. Then the chord joining these two positions, the xt2 and xt1, these two positions, this is xt1, x of t1, and this is the position xt2. These are suppose very close to a position x, of t, which is a function of t. That means at an instant t, the position is x, okay. Then if then we can say that this is very small, del t tends to 0, this tends to 0, right? Then the chord joining these 2 points, xt2 and t1 will almost coincide the tangent drawn at this particular position at this particular point, right, will be this code joining these 2 points, final position and initial position. Okay, this code I am talking about this code joining this xt2 and xt1 when they are brought very close to a position x. This is x at a particular time t. Then if these two are brought very close to this, then the code joining these 2 points, this code joining these 2 points, suppose this is the curve, this is the code. Okay, when these 2 points are brought very close, right, like this. Okay, just now these two are brought very close, this is more closer. Then what will happen? At an instant, this code will coincide the tangent drawn at this point. Okay, so this tangent, suppose this is the tangent here. Just wait. So hope you have understood this concept. Now you see, this del x is also very small now. Separation between these 2 positions, final and initial position, right? It is very small now. Assumed to be 1 point. So the position, the separation between these 2 are very small, so that they are assumed to be a single point at an instant t, right? At an instant t, and the tangent at this point makes, suppose, angle theta with time axis. Then here you see del t tends to 0 because we have taken the difference between this t1 and t2 is very small, tends to 0. Then we will write instantaneous velocity v. This is v. This v represents instantaneous velocity, will be given by limit t tends to 0 del x by del t, and this is written as dx by dt. So this is nothing but rate of change of position with respect to time t, right? And this is instantaneous velocity. This is instantaneous velocity, right? This is instantaneous velocity, and this gives rate of change of x with respect to t, right? So hope you have understood this. This is instantaneous velocity. Now let us discuss about acceleration. Acceleration, you know, rate of change of velocity. If you draw a graph like this, suppose let me write here. This is the graph. So its initial velocity of an object, suppose u, and the final is v. Then you see the change in velocity. The change in velocity during the time period of 0 to t second is given by v minus u. Okay, this is the change in velocity in time t seconds, in the period of time t seconds. Then the average velocity. So let me write v minus u as del v, and this separation between these 2 is, suppose, del t. We have taken this one. Now this is what average acceleration when you take v minus u by t. Okay, this is average acceleration in this time period 0 to t seconds. Now at an instant t, what will be the instantaneous acceleration? When del t tends to 0, then limit dv by dt, sorry, del v by dt, del v by del t. Here del t tends to 0, del t tends to 0, which is equal to dv by dt. This is rate of change of velocity with respect to time t, and this is going to give you instantaneous acceleration. This is instantaneous acceleration, right? So now let me take the example, that first example we had taken. Okay, the first example we had taken. So if you remember, okay, where the position is function of time t, this is the position, this is the displacement, right? This is the displacement, which is the function of time t, right? We have taken that situation again. So suppose we have a question here. Suppose we need to calculate the instantaneous velocity at 5 seconds. So velocity at 5 seconds means instantaneous velocity at 5 seconds, not 0 to 5 seconds. Okay, not this period. It is instantaneous velocity. We know that we have already got v is equal to dx by dt. V is equal to dx by dt. And here you see from the above relation we have got x, which is a function of time t, is 0.5 t square. If you differentiate it, so 0.5 is a constant. We know that dt of constant t to the power n is n into t to the power n minus 1, and if you apply here you see n is equal to 2, so it's gonna be 2 into t to the power 2 minus 1, which is nothing but t to the power 1 means t, right? So if you multiply this two, then you will get 0.5 into 2, that's gonna be 1, so t. So this is meter per second, right? So t meter per second is the velocity we have got, and at t is equal to 5 seconds, what will be the velocity? This is the velocity at time t. This is the velocity at time t. It is the velocity at time t. Now what will be the velocity at 5 seconds? So just replace this t by 5. Just velocity at 5 seconds, that's going to be 5 meter per second. Now suppose we need to calculate acceleration at 3 seconds. So we know that acceleration, instantaneous acceleration is dv by dt, and v we have got, v is equal to, we have got t, right? Here we have got v is equal to t. So now let me tell you, this is for only this example, okay? So in different situation, v, it is not necessary that v always will be equal to t. Sometimes v may be equal to twice t, sometimes v may be equal to t squared, okay? So depending on the situation, type of motion, okay, this relation will be changed, okay? So now you see, so let us replace this v by t. Then if you differentiate t and if you apply this, then t to the power 1, t means t to the power 1, then it gonna be t, 1 into t to the power 0, which is equal to 1, so it's gonna be 1 meter per second square. This is the acceleration, okay? So now you see, we have only got 1, so 1 is the meter, 1 meter per second is the acceleration. Here acceleration is constant, actually not changing with time, okay? Acceleration we have got here, we have differentiating dv by dt, we have got a is equal to 1 meter per second square. That means it doesn't matter at 0 second, 2 second or 3 second, so this acceleration is always going to be 1 meter per second in this case, okay? In this case the acceleration is constant. So hope you have. Now let us solve some problems, UHDS questions from NEET and JEE, okay? Then you will understand better, okay? So now, so first let us solve this question. Here two cars P and Q starts from a point at the same time in a straight line, and their positions are respectively given by these two equations xp. That means the position of the car starts from P, right, which is equal to at plus bt square, right, at plus bt square, and the position of q, that is xq, which is a function of t, and ft minus t square, right? So first let me write the given positions of car P and Q. So position of car P is xp function of t, which is equal to at plus bt square, and position of the car Q, that is xq, which is a function of t, is equal to ft minus t square. So here a, b, f, these are constants, okay, constants. Now we need to find time when these two cars gonna have the same velocity, right? First let us find the velocity of this car P, and we know velocity of any object is given by dx by dt. That means time derivative of its displacement, right? So if you differentiate it, then what you will get, a is constant taken out of derivative, then d dt of t, that's gonna be 1, right? So let me write here a only. A dot 1 means a into 1 means that's gonna be a, then plus b is constant, derivative of t square, that's gonna be 2t to the power minus 1, that means 2t. So that's why, let me cut these things. So here we're gonna get 2t, right? 2t. That means we can write a plus 2bt, right? A plus 2bt, that is Vp. Then let us find Vq. So vq, velocity of the car q, that's gonna be derivative of xq by dt with respect to t. We are differentiating. If we differentiate this again, this is t, derivative of t is 1, so f into 1 is simply f, and derivative of t square is 2t, right? So according to the question, we need to find the time when vp is equal to we need to find the time that when vp is equal to vq. When vp is equal to vq, we need to find the time. Then a plus 2b t, this is vp, is equal to vq is this f minus 2 t, right? So this is the relation we have got. Now let me solve here. So let me take this equation. Yeah, this is the equation. Now I'll simplify this equation to get t. So plus 2t f minus a, and t is taken common, 2t is taken common, then we got b plus 1 f minus a. So t will be equal to f minus a by twice into b plus 2 into b plus 1, or you can say f of f minus a 2 into 1 plus b, right? So this is option B. This option is correct. So hope you have understood. Now let's move on to next question. So this is our next question. The displacement x in meter of a particle of mass capital M in kg, small m in kg. So under the action of a force is related to the time. So this particle is moving in one dimension. So time is this. Really, the time is given by t is equal to root over x plus 3. So where x is the displacement, right? So we need to find the displacement. We need to find the displacement when velocity is 0, right? When velocity is 0. So t is equal to root x plus 3. So root x is equal to t minus 3. X is equal to t minus 3 whole square. Squaring both sides, we have got this. So it's going to be equal to t square minus 6t plus 9, right? On applying a minus b whole square formula, we have got this. So let's find a velocity first, as we need to find the displacement when velocity is 0. First let me find velocity. Velocity at time t, that will be given by dx by dt, right? We have already got that dx by dt gives the velocity, right? So at time t, then if you differentiate this, what you will get, derivative of t square is 2t, and derivative of 6t, 6 is constant, derivative of t will be 1, right? Derivative of t will be 1, 6 into 1, that's gonna be 6. So derivative of constant is 0, 9 is constant, so derivative of constant is 0. So that's why we have got v is equal to 2t minus 6. That's what we have got. When v is equal to 0, v is equal to 0 means 2t minus 6, we have got v is equal to 2t minus 6, which is equal to 2t minus 6 is equal to 0. Then 2t will be equal to plus 6. Then t will be equal to dividing both sides by 2, then you will get 3. T is equal to 3 seconds, right? Then what going to be the displacement? Now let us put the value of t here, then you will get that x, that means displacement, right? So, or you can put here t is equal to 3, then 3 minus 3 whole square, that's going to be 0 square is 0. So displacement is 0, so answer is C. So hope you have understood this. Now let's move on to next question. So here is the next question. The velocity of a particle is given by v is equal to at plus bt square, where a and b are the constants. We need to find the distance travel between 1 to 2 seconds, 1 and 2 seconds, right? So here you see, now velocity is given. Now velocity is given, that is a t plus b t square. So we know that velocity is derivative of time derivative of x, right? So when the displacement x, that means the position is given, if you need to find a velocity, then simply we used to differentiate x with respect to t, right? But when velocity is given, you need to find displacement, then what are you going to do? So if derivative of x gives velocity, then remember integration of velocity will give displacement. So that means velocity is obtained by differentiating x. So this is differentiation. Okay. Then integration of v will give you displacement. If you have velocity, you need displacement, then you have to integrate the displacement, right? So hope you have understood this, because you see, let me tell you here, as v is equal to dx by dt, derivative of x with respect to t gives v. So here, how to obtain the x, v into dt? So integrating both sides, we're gonna get the x, right? So dx of the integration will be x, so v dt. So that's how we can obtain displacement or position. So here you see, so that's why what we're going to do here, so simply you can write dx by dt, v is written dx by dt, a t plus b t square. So as you can see that a and b are constant, right? Or let me use this relation instead of writing this way. So let me just write here like this: x is equal to integration b dt, that means integration a t plus b t square dt, right? So constants can be taken out of the integral. So a integration t dt plus b integration t square dt, we can write that way. Okay, just let me write it clearly, t square dt. That's how we can write. Yes. So now let me clean these things. Okay. So now you can see, if you integrate t, so I have already told you that integration of t to the power n dt is t to the power n plus 1 by n plus 1, right? So here, when you have t to the power 1, that means t dt, then you will get t to the power 1 plus 1, that means t square by 1 plus 1, that means 2, right? So here we will get a t square by 2 plus b t cube by 3. Applying this formula, we will get t cube by 3. That's what we will get. This is the displacement, right? So we need to find the displacement between 1 second to 2 seconds. So I have already shown you how to use the limits, right? Upper and lower limits. So 1 second to 2 seconds. So 1 second to 2 seconds. We need to find the distance travel between 1 second to 2 seconds. So what we should do, as already I have told you, what we have got, x is equal to this, right? Let me copy these things. Okay. So this is the result we have got. First, what we need to do, first we need to put the upper limit. So then what we will get, a into 2 square by 2 minus, then let's put the lower limit here, then 1 square by 2, right? Similarly, b into, put the upper limit 2 here, then you will get 2 cube by 3 minus, put the lower limit here, then 1 cube by 3, right? So if you simplify this, then what you will get here, it's gonna be 4 by 2 minus 1 by 2 plus b 8 by 3 minus 1 by 3. That's what we will get, right? So let me clean these things. Okay. Now you see, this is x, what we have got, x. So let's evaluate this. So let me write here. Okay, then if you subtract these two, then what you will get? 3a by 2. And if you subtract these two, then what you will get? 7b by 3. So this is the displacement we have got. So which option is correct? Option C, right? So C option is correct. So hope you have understood this. Now let's move on to the next question. So here is the next question. So here is the next question. A car moves from X to Y with a uniform speed of VU and returns to X again with uniform speed VD. So here you say this is point X, so this is X, this is Y. A car from this X position, this is the car from this position, it moves to Y, right? It moves to Y, again it comes back to the initial position, and from X to Y it moves with the velocity, uniform velocity VU, and comes back with VD, right? So if we consider that length of the path be suppose L, let me consider that way, right? Then total distance covered will be twice L, right? So L again coming back L, right? So what will be the time taken to cover the distance L while going from X to Y, right? We know that speed is equal to distance by time, then time will be equal to distance by speed, right? So time is equal to distance by speed. Right? Time taken is equal to distance by speed, right? So time taken to reach the point Y while going from X will be L by VU, right? Because while going from X to Y, what will be the time taken? T1 will be, so length of the path we have taken L, this is the distance covered while going from X to Y, and divided by the uniform velocity VU, then it's gonna give time taken to cover XY, right? Then again from Y to X, while it is coming back Y to X, then what will be the time taken here? Distance is same L, and time and the speed, now uniform speed is VD, right? So this is the time. So total time will be T is equal to T1 plus T2, that's gonna be L by VU plus L by VD, right? This is the total time taken, and here we have got total distance covered, we have got total time taken, and the speed, we know that average speed is given by total distance covered by total time, right? Here the total distance covered is twice L, and time taken is L by VU plus L by VD. So what you will get if you simplify this? So let me clean this all these things. Let me clean this all things, right? So now you see, so from this relation what you will get, so 2L by here L is taken common, 1 by U, sorry not U, 1 by VU plus 1 by VD. So L gone, and if you take LCM here, VU into VD, then here you will get VD plus VU, right? And who is gonna give you 2 VU VD by VU plus VD, and which option is correct? So option D. The option is correct. So hope you have understood this. Now let's move on to next question. So here is the next question. The velocity, the speed of a moving object is given. This is the speed in terms of displacement, it is given along the positive x-axis, and we need to find the speed of the particle at time t is equal to tau, right? So, and assume that particle is at origin when t is equal to 0. When t is equal to 0, particle is at origin, that means at x is equal to 0. Okay, so when t will be equal to tau, the position will be equal to x. Let me assume that way, right? So here this velocity v is given by b root x, right? So we know that v is equal to dx by dt, so b root x, so dx, this relation can be written as 1 by root x dx is equal to b into dt, right? So now let us integrate in order to calculate the value of x. Let us integrate both sides. So if you integrate both sides, then what you will get? 1 by root x dx, b is constant, can be taken out of the integral dt. So here you see we are integrating from 0 to x, and this time component is integrated from t is equal to 0 to tau, right? 0 to tau. So 0 to tau, x is equal to 0 to x is equal to x, right? So then what you will get? An integration of 1 by root x dx means what? 1 by root x means x to the power minus half, right? If you integrate this, right? So here we're going to apply this integration x to the power n dx, that is x to the power n plus 1 by n plus 1. So if you apply that, x to the power minus half plus 1, that's going to be x to the power plus half, right? Divided by minus half plus 1, which is equal to x to the power which is equal to plus half, right? Then again we have limits from 0 to x, right? From 0 to x, so this is going to be nothing but 2 root x. So if you put first we need to put the upper limit, right? Then lower limit. If you put the upper limit, then you will get 2 root x only. If you put the lower limit, then you will get 0. So simply we get 2 root x on the left hand side. On the left hand side we have got 2 root x, and on the other side if you integrate dt, then you should get t, right? You should get t. So we are integrating it from 0 to tau, then this is going to be equal to, first upper limit, this t is replaced by the upper limit, then minus t is replaced by the lower limit, which is 0, right? Then this is equal to b tau. So what will be the value of root x? Root x will be equal to b tau by 2. That is the value of root x, b tau by 2. Now let us use this value of root x here in this relation, because you see v is equal to b root x, v is equal to b root x. So let us use this value here, and if you use this value here, then what you will get? V is equal to, so b into root x is replaced by b tau by 2, which is going to be equal to, so let me clean these things. So now v is equal to b into b square tau by 2. So this is the answer. So which option is correct then? Option B. So hope you have understood this. Now let's move on to next question, right? So this is the next question. The position of a particle as a function of time t is given by x of t, which is equal to a t plus bt square minus ct cube, right? So this is what given, right? So let me just, so this is x given. So where a, b, c are constant. When the particle attains a zero acceleration, then its velocity will be, so what will be the velocity when a is equal to 0? Acceleration is equal to 0, right? So here it is given that x of t, the position is given, that is at plus bt square, right, minus ct cube, right? This is the position. So first let me find the velocity at time t. So this is the position at time t. So if you need the velocity at this time, then you have to differentiate x with respect to t. Then if you differentiate this is constant, and derivative of t is 1 into a is simply a, and if you differentiate t square, then you will get 2t, right? So 2bt, as there is b constant, then minus 3ct square. So hope you have understood this, you know this differentiation, how to do it. So I have already given the formula, that just I have applied this one, dt of t to the power n, this is n into t to the power n minus 1. And if you have a constant, you should keep the constant outside the derivative, right? So that is what we are doing, okay? So now what will be the acceleration? Acceleration is again dv by dt, right? Acceleration is again dv by dt. So if you differentiate it again, so a is constant, derivative of constant is 0, so then derivative of 2bt, and derivative of t is 1, so we're gonna get only 2b here. Then derivative of this t square, again 2t, this 2 and 3, that's going to be equal to 6, right? 6ct, that's what we're going to get, right? So we need to find velocity. We need to find velocity when a is equal to 0. When a is equal to 0. When a is equal to 0, so we have got, this is a, so we can write 2b minus 6ct is equal to 0. And if you simplify this, just wait. So let me write this condition here. So if you simplify this, then what you will get, 2b is equal to minus, sorry, it's going to be plus 6ct on the other side of the equal sign. Then b will be equal to 3ct, dividing both sides by 2. Then here t will be equal to b by 3c. Now we have got t. So as we need to find v when a is equal to 0, what this value of t we obtain here when a is equal to 0, okay? So we need to find the velocity when a is equal to 0, right? So here you see, as we have already got the value of t when a is equal to 0, we have got the corresponding value of t. So that's why put t here, value of t here. This t are replaced by this value of t. Then v will be is equal to a plus 2b into t is equal to b by 3c from this equation. Then minus 3 into 3c into t square will be b by 3c whole square, right? So we have used this value in this equation, right? So then what you will get, now you will get v is equal to a plus b square, so 2b square by 3c, then minus 3c b square by 9c square. That's what we have got. So now you see, let me clean this part. Now we don't need the things, okay? Just wait. Okay, let me bring this step here. Okay, just So now here you see this 3 cancels 9 and goes 3 and gives 3, then c cancels c square to give c, right? C square to give c. So what we have got, a plus 2b square by 3c minus b square by 3c, and if you subtract these two, then what you will get, a plus b square by 3c. So this is the velocity we have got, right, when acceleration is equal to 0. So which option is correct here? So if you observe the options, then option C is correct, right? So hope you have understood this. So we're gonna solve more problems in the next upcoming lectures, because I need 4 or 5 more lectures to complete this chapter, right? So in the next video we're gonna discuss about the graphs, different graphs, position and time graph, velocity and time graph, acceleration and time graph of different motions, and we also talk about the equations of motions, different equations of motions. Then we're gonna solve more problems from JEE and NEET related to those topics that those gonna be discussed in the next video, right? So stay connected, and if you like my videos, please share with your friends, hit the thumbs up button, also hit the bell icon so that you get notified when new video will be uploaded. And if you haven't subscribed yet, please subscribe and support me to create new contents for you, inspire me to create new contents for you, okay, and help me to grow my channel. So thank you for watching. See you in the next video.